All right. Hello. Greetings. Welcome in. If you're watching, um, I am Professor L, and I'm doing this live stream for math engagement. So if you do have a problem that you would like to see me work out, you can post it in the chat. If I don't know how to work it, I will just say I don't know how to work it, and I'll probably go figure it out because I like to learn new things. But if I do know how to work it, I will do my very best to give you a good example. So that's really the intention. However, I am using this time to practice my math because I'm so busy right now in my life that I don't really have a lot of time to spend on the math. So anyway, I am going to be correcting my mistake from yesterday and reworking this matrices. So I apologize if you're bored with this problem, but it's important for me to find my mistake and to fix it. And so I I do feel a little bit, disappointed in myself because I should probably practice before I work on my board. However, I'm just not there yet. I just don't have the time to work problems over and over again. And it's just, it's a busy modern world we live in. So I am trying to just make the most of this time and practice on my board, extremely informal. And yeah, if you know, want to come hang out with me and do some math, we have strength in numbers, so it's always better to do the math with many people, like as a group. So I was hoping that through this platform that I could establish something like that. I know that there's not a lot of people doing using this platform for group study of math, and so I really want to make sure that I am doing my very best to set a good example of the learning process and what it takes to diligently learn the math. So I'm going to just rework this problem. I found my mistake very quickly, and that was the disappointing part of it, is that I wish that I would have just been patient and recalculate the determinant, because I remember yesterday that I knew the determinant was wrong. It was entirely too large. Usually when you calculate a determinant, it's not going to be 3 digits. So I wish I would have, just me reflecting on yesterday and just trying to slow growth. Any type of growth is good, and even if it's a slow growth. So I feel like it's me personally growing in learning how to engage with the lens, the camera, and yeah. So I'm trying to work to be really good at presenting content to students. And so yeah, it's just me practicing. Anyway, happy Thursday. I hope everybody's doing fantastic. And yeah, I'm just going to go ahead and get into it. So I'm going to keep this system because I know I wrote it correctly. And I can also keep this because this is essentially what I'm doing here. I split my system of equations up into 3 matrices. So the first matrix is a 3x3 matrix, and it's consisting of just my coefficients of my variables. Then I have a matrix for just my variables, and I've set that equal to my constants. And so that's kind of how you would set up the matrices to solve, or a system to solve using matrices with this method. And I will remind that there are multiple ways to solve systems of equations with matrices. And so I'm really wanting to, after I've got a firm, solid grasp and I'm confident with this method, I want to be able to move on and show how to augment a matrix and solve it using Gauss-Jordan elimination. So that's coming next. And so for now, I need to go ahead and sharpen my skills a little bit. And so I really appreciate everyone being patient with me, and yeah, while I'm learning and growing. And so hopefully by this time next year, I can just spit out really quick 5-10 minute lectures for people. And so we'll just see if I get there. All right, so enough of the chit chat. I'm going to erase my determinant because I know that's where the mistake was. Work this problem and try really hard to not say, I noticed that reflecting on my videos, I say, entirely too much. And hopefully this is going to help me to, just say it again. Yeah, so, all right. Determinant's definitely not negative 228. So see if we can get that pretty inverse rather quickly. Okay, so here we go. Step 1, determinant. I just list the steps. And in math, most of the definitions are useful. So words sound like what they mean. And the determinant is named the determinant because it helps you to determine whether the matrix is invertible. If the determinant equals 0, the matrix does not have an inverse. So that's why I do that first. So we're just going to go ahead and start by listing my coefficient matrix. We got -3, -6, -15, 2, 3, 9, -4, -7, -17. And I realize that part of it, and this is why I'm not really beating myself up too much about my mistakes, is because I have been camera shy my entire life. I don't like taking pictures. I don't like people taking pictures of me. And it's just something that I have to move past and grow in order to be successful with this platform. And I have shunned social media my entire life. And people that know me know that. And it's just because, I said it again. All right. So what I did, my mistake, was the previous video we can go back and watch, but I, instead of doing -3 and -17, I did -3, 3, and 9. It's really specific to the diagonal. So I needed to do those 3 numbers. Then it's going to be these 3 numbers, and then it's going to be these 3. So what I need to do is I just need to slow down, be more careful, and breathe. So we've got -3 times 3 times -17. And I will use parentheses to group to keep track of my order of operations. And I have -6, 9, and -4. And then that's plus -15, 2 times -7. So the forward slashes get plussed and the backslashes get minused. So we'll have a minus these 3, which is -15 times 3 times -4. These 3 are -7 times 9 times -3. And then one more diagonal, we've got minus -17 times 2 times -6. And it's important to include these parentheses so that you don't leave off negatives, because it is very, very easy to make minor arithmetic errors. Most of the errors that occur in upper level math calculations occur in a minor arithmetic. I said it again. So that's going to be really annoying until I learn how to not say all the time. I have a pretty developed vocabulary and I just need to use it. So we've got two negatives, make a positive, and I've got, this will be positive 153. Just multiply -3, +3, -17. So we're going to do these three. So we got 6 times 9 times 4. 2 negatives make a positive. So it's positive 216. And then we have -15 times 2 times -7. I'm getting 210, and 2 negatives make a positive. All right. We have the pluses, so we're going to go to the subtraction now. So we have -15 times 3 times -4. And that is a positive 180, but you've got a negative here, so that's going to make it a negative 180. The next term here, we've got -7 times 9 times -3. And 2 negatives make a positive, and then another negative is going to make it negative again. So that is going to be negative 189. And then 17 times 2 times -6. Is 204. 2 negatives make a positive, another negative is going to return negative. So we should have this. All right, so I like to add all the like signs first. So we've got 153 plus 216 plus 210, and that's going to give me 579. And then we have 180 plus 189 plus 204, and that is giving me 573, and it's going to be negative. So minus 573. So we've got 579 minus 573, and it looks like it's 6. And just being very careful, especially being on the camera in front of, like, literally live on TV. Just in case somebody's watching, I really don't want to be messing up as bad as I did yesterday. Like, it was so ridiculous that I literally made the mistake within 5 minutes of work, like the first 5 minutes of working the problem. And that I just wish if I could go back and redo it again, and I'll do this next time if that happens, and I know the determinant's off, then I will just go recalculate it, because that could have saved the whole thing. I could be doing a 4x4 right now if I hadn't done that. So I have to reflect, and I have to be critical of myself so that I'm growing. So D equals 6 here. And that sounds a little bit more, that's more reasonable for a determinant. Right, so now I've not, step 2, I've got to calculate my matrix of minors. So we'll put that in there. Step 2. Right. So we'll go ahead and start that. And what I like to do is I just like to get it set up. I could just plug in the numbers. And this is so good. I really enjoy writing this out, working out the math on this board. It's totally different than doing it on scratch paper. I remember sitting in my college classes and just being so impressed by my professors, how they could just write out all of the math on the board. And one day, maybe I will be that good. All right, so we're going to start by crossing out the rows and columns of the positions that we're looking for. And I remembered what they're called, these elements. So they're called elements. So this is row 1, column 1, row 1, column 2, row 1, column 3, and so on and so forth. So they're named, but they're elements of the array, which is called a matrix. So, all right, we've got 3, 9, -7, and -17. This one is going to be 2, 9, -4, -17. And then this one is 2, 3, -4, -7. This one is 3, 9, -7, -17. I like the middle one the best. It's just the corners. -3, -15, -4, and -17. This one is going to be -3, -6, -4, -7. This one is -6, -15, 3, 9. I don't want to mess up again. So I really didn't have to recalculate this matrix of minors. I'm just doing it for pure fun. I'm giving myself a hard time because I made that tragic mistake and I just need to learn to be more careful. And my brain is very stubborn. So if I don't put myself through a little bit of criticism, then I won't learn. I won't make the adjustment. I'll just keep doing what I always did, making mistakes. I really want to grow, so I need to make sure that I'm hard on myself a little bit. So that one, make sure it's correct. 3. Okay, good. I got it. Mess it up? No, it's correct. 2. And this is the problem of doing math in the evening, exhausted. Okay, so 3, 15. It's 2 and 9. Okay, finally got it. So then this one is just going to be those 4 corners. So we've got -3, -6, 2, 3. Perfect. All right. So once we've got our matrix of minors, then what we need to do is we need to go ahead and calculate the determinants. So they're minor determinants. That's what they mean by minors. So we'll just make it a little bit smaller. And we'll do this one first. So I'm going to go through this pretty quickly because I've reworked this by hand. So it's 3 times -17. Is 51. So it's going to be -51 minus 63. -63. So the negatives are really important. So when you multiply a negative and a positive, you get a negative. However, with the determinants, the rule is that you plus the forward. The forward is a plus and the backslash is a minus. So you have to include the extra negative in order to get the right answer. So 63 and 51. I believe it's 8. Or no, that would be 12. 12. All right, 63 minus 51 is 12. And we've got a negative 51 and a positive 63. So that's gonna, that first position is giving me 12. All right, so this one, we'll do this one next. We've got 2 times negative 17 minus negative 4 times 9. So 17 times 2 is 34 negative, and 4 times 9 is 36. Negative, negative, positive. 36. So this one is going to give me a positive 2. Then we have this one. This is a 2 times negative 7. And that's minus negative 4 times 3. So 2 times negative 7 is negative 14. And negative 4 times 3 is negative 12. Times a negative makes a positive 12. So this is going to give me negative 2. We'll do this one next. So we've got 3 times 17, negative 17, minus negative 7 times 9. So this is negative 51. And then 7 times 9 is 63. It's going to be positive. So this is going to be 2, positive 2. And then this one, negative 3 times negative 17 is going to be positive 51. And then we have minus negative 17 times 9. I said 17. It's negative 7 times 9. 51 minus 7 times 9 is 63. And it's looking like another positive, negative 12. So it's going to be negative 12 this time. It's negative 63. And then we've got this one. 7 times 3 is 21. We'll erase all this anyway. So 7 times 3, they're both negative. It's going to make positive. Minus negative 4 times negative 6. So this is positive 21. 2 negatives make a positive, and now it's going to be negative. So 4 times 6 is 24. So that's going to give me 3, negative 3. All right, so then we have 6 times 9, negative 6 times 9, minus negative 15 times 3. 6 times 9 is 54, and it's negative. 15 times 3 is 45. Negative makes a positive. So that is going to be, it looks like negative 9 here. And 2 more. So we've got negative 3 times 9 minus negative 15 times 3. So 15 times 3 again is 45, negative, and then it's going to be positive. All right, so 9 times 3 is negative 27. And then it's going to be plus 45. Oh, wait a second. I'm going to get the wrong answer. I just caught another mistake. So it's really good if I'm able to catch the mistake right after I make it. So that's ideal, and I will reward myself for that, not punish. All right, so we've got 3 times 9, and we have 15 times 2 here. So I almost messed up and multiplied by 3. And again, this is part of just not having it pre-recorded. All right, so 15 times 2 is 30. 2 negatives. All right, 30. And so 30 and 27 is positive 3. And then we've got one more. All right, so it's negative 9. 3 times 3 is 9, and it's minus negative 12. So that's going to be negative 9 plus 12 is going to give me 3, positive 3. All right, so hopefully I have calculated that matrix of minors correctly. I don't recall what I got yesterday with it, so we'll just have to, I'll go back later and compare it. All right, so I have to assume that that's correct. And I have to erase my scratch. All right, so step 3, we're going to take this matrix of minors and we're going to apply the rule for cofactors. So in this rule for cofactors, what we're doing is we're multiplying either by a positive or a negative 1, depending on the location of the element in this matrix. So we're going to say step 3. We'll do step 3 here. We're going to apply cofactors. Okay, so the cofactors, we'll just put it right next to it. It's plus, minus, plus, minus, plus, minus, plus, minus, plus for a 3 by 3. And it will always be this way. So there is a formula to how we get this cofactor, and I did learn it, and I remembered learning it, and I went and looked it up. I may show it next time. I really haven't decided. All right, so 12 is going to stay positive. We're just going to make a new matrix. 2 is going to go negative. This one is going to stay negative. 2 is going to become negative. Negative 12 will stay negative. Negative 3 times a negative is going to become positive 3. Negative 9 and 1 is going to stay negative. This 3 is going to become negative, and then this 3 is going to stay positive. All right, perfect. Hopefully. All right, so now we have to transpose this matrix. So we'll say step 4, transpose. And how you transpose is you take the diagonal stays, and so we have 12, negative 12, and 3. And then we're just swapping out. So 2's are going to stay the same because they're the same element. Negative 2, negative 2. The negative 9 is going to swap with that corner, negative 2. So this will be negative 9. Oops, I almost didn't do it. This is what happens when you don't get enough sleep. So -2, -9. And then one more, -3 is going to swap out with +3. So this one is going to become positive, and this one will be negative. Perfect. Okay, got it. All right, scoot it over just a little bit to keep everything consistent. All right, so I believe the only thing left to do, so this should be hang on a second. This is not. I'm pretty sure I have the inverse calculated here, and it's not. Let me go back into my calculator. And I also remember that there is a way to calculate the determinant of A. So I want to go ahead and do that real quick in my calculator. Yeah, it's saying the determinant's correct. Let me see if there's a way to get the cofactors. Okay, I don't see it immediately. However, when I calculate the inverse, I got a different number, so I'm going to redo it. Okay, so it looks correct. What we have to do now is we have to multiply by the determinant. Okay, so step 4, this will be step 5. We're going to multiply each element in this matrix that we found, the transpose. It's actually, this has a special name. It's called the adjoint matrix. So we'll put this in here in parentheses. So that's the adjoint. So I didn't list the formula, but we can go ahead and do that for A inverse. This is the formula I'm using. It's 1 over determinant of A times the adjoint. So I have the adjoint. Now I have the determinant. All right. So this is what we're going to do. Multiply by 1 over the determinant of A. So 1 over 6. Each element gets multiplied that way. So we'll have a new matrix. We'll stay here. It's 12 times 1/6 is 2. 12 times -2. Let's see. I may have to erase a little bit more. Let's erase this down here so I can do the work in here. I need some scratch paper. Okay. So we've got 1/6 times -2. So that is going to equal -2/6. And then what we have to do is we're going to reduce down. So 2 goes into 6 3 times. So it's going to be -1/3. And we'll go back to this value here. We've got negative 9 times 1/6. So that's going to be negative 9/6. And what I'm doing is to reduce these fractions is I'm just splitting it up into its prime factorization. It's 3 times 3 and 2 times 3. And we're just crossing out like terms. Anything divided by itself is equal to the quantity 1. So this is going to give me negative 3/2. All right, so this one, negative 2 times 1/6 is negative 2/6. 2 goes in 6 3 times, so it's negative 1/3. Negative 12/6 is negative 2. Negative 3/6 is negative 1/2. And 2/6 is negative 1/3. And 3/6 is 1/2. All right, so this is our inverse. So final step, and again, this is probably the reason why this method would not be best to solve a 3x3. If I were going to, if speed was a factor and I needed to do this in as least steps as possible, I would use algebra. What this is practice, because if you have a system of equations with more than 3 unknowns, you will have a total of 4 equations, and you would use this method because it would be easier. So this is a better method if you have a bigger matrix. So we're practicing it with smaller numbers so that we can get good at it, so that later on when we need to calculate it with larger numbers, we will have the method down. Because a 6-step method is kind of complicated in math, so it does take practice. All right. All right, so step 6. What I need to do is I need to multiply A inverse times my constants. So we'll say multiply inverse by constant matrix. And I wasn't going to put the formula, but we'll do it. X, Y, Z equals A inverse times your constants. So let's go ahead and put it all the way here. Right. So we just multiply by the constants. Negative 3, 1, and negative 4. I just have to be patient with myself until I get more comfortable with the platform, because most of my mistakes will subside as I become more comfortable and confident with math. So negative 3 times 2. 3 times 2 plus negative 1/3 times 1 plus negative 3/2 times negative 4. So this is going to give me negative 6 minus 1/3 plus 12 halves, which is 6. So we've got -6 minus 1/3 plus 6. So this is just -1/3. And I don't think that is correct. Unless I wrote it down correctly, let's double check that solution. I am pretty sure that it's supposed to be 1/2. So there is another mistake. Let's go ahead and calculate the other one. I must have made another arithmetic error. Gosh, this is so tragic. But -3 times, maybe I can just find it real quick. And it's the scary part of doing math live, especially when you have not had near enough sleep. So let me just step back here and think about it. Shoot. My determinant is correct. Well, divided by 6 is 2. Two divided by 6 is -1/3, and 9 divided by 6. All right, let's just recalculate these and back up. The method's not going to change, but actually, let's go ahead and just double check and see if we got the inverse correctly. So we have, say, I still have it stored in my calculator. So again, it's good for me to set an example of the learning process and me engaging with the math. In math fraction form. All right, so 2 1/2 -3/2. So why is this 1/2? I applied the cofactors. All right, it's saying that this is not -3, it's saying it's -1/2. So we would get the right answer if we fix that. But I still want to know exactly what I did wrong. So what I'll do is I'll go ahead and leave it 1/3 and I will work it again. Not right now because I'm already 40 something minutes in. But let's go ahead and see if we get these other values. So X is going to be wrong. So X equals -1/3 is not correct. That's right. Move on. All right. So we've got this row times this column. And so we'll just do it real quickly. -1/3 times -3 is going to be +1. -2 times 1 is -2. And -1/2 times -4 is +2. I'm pretty sure I did that negative. I didn't even check the other values. -1/3. -3/2, that's wrong. And -1/2. All right, -1/3, 1/2, and 1/2. So these are all correct. So I'll get Z. However, Y is saying it's 1. So it's saying Y is 1. And that is also not correct. So Z will be correct because this is correct. And this is correct. So -1/3 times -3 is +1. 1/2 times 1 is +1/2. And 1/2 times -4 is -2. So we'll add those numbers and we're going to get an improper fraction. So this is going to be, so 1, that'll be 2/2 plus 1/2 minus 4/2. So this is 2 plus 1 is 3 minus 4. 3 minus 4 is -1, and then it's divided by 2. So it looks like C is correct. So I was able, after 45 more minutes of work, I was able to at least get one of the values. And matrices are fun, but it's not a practical way by hand to solve. I think the biggest use for matrices is to teach AI how to solve matrices and just let it do it. The computers are amazing. All right. I was so confident too. I was just, well, I think I was just a little bit too confident. So we've got one of the 3 solutions, and I need to figure out what exactly I did. So I will rewatch the video, find my mistake, and we will just, I don't know for sure what I'm going to do tomorrow because I'll sleep on it and I'll wake up and I will decide whether I want to rework the entire problem or just come back in here and find the mistake. But it's not as bad of a mistake as yesterday. So it must be something minor because I was able to calculate Z. So I hope that tomorrow will just be a really short video of me finding this mistake and correcting it. And then also, I hope that the pain of not getting this problem correctly is motivation enough for me to start going ahead and being a little bit more prepared for my live streams. So while I realize that mistakes are important and how you handle mistakes are very important, however, I need to make sure that I'm not giving my viewers a hard time. So I will go ahead and end this for now. And I will say thank you so much for watching my video. I greatly appreciate it. It's a way of silently supporting me. And it makes me feel good knowing that I'm not up here just doing math to a blank audience. It's awesome. Even if I was only able to help one person, it would make it worth my time, to be honest. So with that said, I will stop rambling and I will say I hope you have an amazing rest of your Thursday evening. And yeah, I will be back tomorrow, same time, same place. And I will say bye for now, and I will see you all next time.